algebra students, Mr. Lawrence here, and this is a test review video. We're going to have your test on Tuesday, which would be the 10th, I think, February 10th. Yeah, we're going to have your test then, because we could have had it this week, but with the testing scheduling, 8th period fell a little bit behind because they didn't get to have classes often, but I think by Tuesday they'll be caught up. So, remember, you've got that review sheet. I gave it to you in class on today. Oh, by the way, Allison Pasquale, I'm making this video right after I finish that yummy piece of chicken. I'm so glad you were there to watch me eat it. Anyway, so you've got the review sheet. You need to have that completed by Monday. We can go over some stuff. If you've done some work on the problem but can't get the right answer, that's fine, but you need to have attempted every problem to be in the drawing to get the ice cream sandwich or the treat at lunch. All right, so first of all, we have to know how to write functions, right? And remember, there's different types of functions we know how to write: linear, quadratic, cubic, exponential. A linear function might look something like this, f of x, and then it would be what? Like maybe a 3x minus 5, right? We'll have a sequence of numbers that'll get us this function, but you should know how to do it. You should know it's linear because it's to the first power, right? Okay, now how do you recognize when a set of numbers is going to produce a linear function? Well, the first differences are constant. The first differences match. The first differences are all the same. Okay, and we'll do some. I'm just made you a little study chart here. You might want to use this. Quadratic, that might be something like g of x equals, say, a 10x squared plus, I don't know, 1. Something like that. That'd be quadratic because it's the second power. And that's when the second differences are the same. And this is kind of subtle. Make sure you get this down. Second differences are the same. But the coefficient, this 10 here, would be 1/2 of the second differences. So in this case, when I got to the second differences being the same, they would have all had to have been plus 20. Plus 20, plus 20, all on that second level. Pardon me while I close my email. All right, so if it was plus 10, then it would be a 5x squared. Remember that? Okay, cubic. A cubic equation might be something like f of x equals x cubed minus 2, something like that. Okay, and that's when the third differences are the same. And remember, I suspect that's going to be a 1/6, but you won't run into anywhere you have to divide by 6. They're just going to come out to be a 1x cubed. For this level, I think that's sufficient. All right, and then exponential, that's the one that gave some of you some trouble. Exponential might be like h of x equals 4 to the power x. And we know something is exponential because the differences are being multiplied, right? The differences are being multiplied. All right, so now I'm going to do 4 examples. And, if you like, you go ahead and you pause. This is problem number 1 here. I've given you a set of 5 numbers. I want you to write a function. I want you to determine what type of function it is: linear, quadratic, cubic, exponential. And then I want you to find out what f of 30 is. Okay? So it'd be great if you paused and tried to figure this out on your own. But here I go. So if you want to pause, you go right ahead. Set up my table, x and f of x. And then I'm going to have what? 1, 2, 3, 4, 5, and I'm looking for the nth term. And I've got 1, 5, 9, 13, and 17. Now I go and find my first differences, and I see what happens with my first differences. So it looks like the first difference is plus 4, and then plus 4. Ooh, it's plus 4 every time. All right, that means this is a linear function, right? It's going to be a linear function because the first differences were the same. All right. And I'm going to take this 4 and I'm going to multiply it by n, by the nth term. So I'm going to go 4n. I got to tell you, some of the honors kids had a real tough time with this test. Part of the reason was they weren't doing the comparison line. They were trying to figure it out in their head. I taught them the comparison line, but they didn't do it. So make sure you're doing the comparison line. And remember, if you're Dan Michael, you like to go like this: 4 times 1, 4 times 2. He likes to write the problem underneath and then put the answer up there on the blank. So that's how we set it up. So 4 times 1 is 4, 4 times 2 is 8, 12, 16, and 25. No, 20, excuse me. All right, so now I'm ready to compare. So how do I turn 4 into 1? Well, I subtract 3. 8 to 5, I subtract 3. 12 to 9, I subtract 3. 16 to 13, I subtract 3. And 20 to 17, I subtract 3. So what am I going to do to n? Well, I'm going to go 4 times n and then minus 3. Now that's only the expression. The function is going to be f of x equals 4x minus 3. Now the third thing I need to do, I found out what type of function it was. I wrote the actual function, and now the third thing is I'm going to find f of 30. So I'm going to go f of 30, and I'm going to go 4 times 30 minus 3. And 4 times 30 is 120. Minus 3 is going to be 117. And there you go. The 30th term in the sequence will be 117. All right. Oh, we went too far. Okay. Number 2. Let's see if I can get this to sit down for me here. Seems to be scrolling an awful lot. I want to move this stuff up a little bit, give myself some more room to work. Oh, it doesn't like that. Oh, stop it. There we go. Let's see if I can control G and move that up. Okay, same type of problem. I'll go ahead and make my table. Again, I'd love for you to pause at this point. Okay, make your own table, and well, it looks like I'm going to go g of x because it's asking for g of 10. The letter of the function doesn't really matter. Okay, so let's see, 1, 2, 3, 4, 5. I'll need the nth term. And let's see, -9, -2, 17, 54, and 115. And then I'm going to find my first differences. So it looks like it's plus 7, and then it's plus 19, and then it's plus 37, I think, and plus, is that 61? I think that is 61. All right, no dice. It's not linear because the first differences don't match. Let's go down to the second differences. Plus 12, plus 18, and plus 24. It's not quadratic. If it was quadratic, these would all be the same number. Oh, let's go down to the third level, and I get plus 6. It must be cubic. So therefore, for the nth term, I'm going to have an n cubed. All right, now I'm going to do that comparison line. I'll get rid of these differences so that they're out of my way. I'm going to do that comparison line. 1, 2, 3, 4, 5. Again, if I'm Dan Michael, I'm going to go 1 cubed, and 2 cubed, and 3 cubed, and 4 cubed, and 5 cubed. So I cube 1, I cube 2, I cube 3, I'm going to cube 4, and I'm going to cube 5. And then I'm going to see how do I turn 125 into 115. I take away 10. 64 to 54, take away 10, take away 10 every single time. So it's going to be n cubed, the nth term will be n cubed minus 10. And therefore my function is g of x equals x cubed minus 10. Now I forgot to mention, write down anyway, that it is a cubic function. It's a cubic function. So there's what type of function it is. There's the actual function, and now I'm going to find g of 10. So step 3 will be find g of 10, and I'll get 10 to the third power minus 10. Well, 10 to the third power should be 1,000, and minus 10 would be 990, and there you go. That's the 10th term in the sequence. All right, how about this one here? Okay, again, please pause the video. Here comes my solution. I'm making my table. I got 1, 2, 3, 4, 5, and then n. And I need 5, 22, 51, 92, 145, hike. All right, so go find the first difference. It looks like I have a plus 17. And here, I think that's a 27, right? Yeah. No, that's not right. That's not right. Wow, I got a mental blank. 29. Yeah, 29 looks right. There we go. Okay, plus 41. And that is going to be 53, I believe. Not linear. First differences don't match. Let's go on to the second differences. Looks like that's plus 12. Looks like that's plus 12. And that's plus 12. This is quadratic. It's a quadratic function because the second differences are all the same. Now, I'm going to take half of this number, which is 6, and multiply it by n squared because it's quadratic. So my test line will be 6n squared. I think this function is going to be very similar to 6n squared. All right, so let's take 6 times 1 squared, 6 times 2 squared, and 6 times 3 squared, 6 times 4 squared, and 6 times 5 squared. All right, so 1 squared is 1 times 6 is 6. Remember, you got to follow the order of operations. This is not 6 squared. It's 1 squared times 6. 2 squared is 4 times 6, 24. 9 times 6 is 54. 16 times 6 is 96. 25 times 6 is 150. So I'm going to ask myself, how do I turn 6 into 5? Well, I subtract 1. 24 to 22, well, I subtract 2. 54 to 51, minus 3. 96 to 92, minus 4. 150 minus 5 is 145. So what am I going to subtract from 6n squared? Well, on the first one I subtracted 1. Second one I subtracted 2. Third one I subtracted 3. Fourth term I subtracted 4. On the nth one I'm going to subtract n. And so my function, which is quadratic, will be f of, it's h this case, I'm sorry. H of x is going to equal 6x squared minus x. Now to find h of 8, because I'm asked to, I'll go h of 8 equals 6 times 8 squared minus 8. 64 times 6. 64 times 6. It's going to end in a 4. 384, I believe. I just evaluated that. Minus 8. If I take 4 away, I get 380. I take 4 more away, I get 376. There you go, 376. All right. So, one more example here. Again, this will be a little bit longer of a video, as you can tell, but that's because it's a review and you have the whole weekend to watch it. Whoa, what the hookah waka is going on here? All right, stop right there. Thank you. All right, so go ahead, pause it, make your table. X and f of x. Okay, 1, 2, 3, 4, 5, and n. First term is 5, second term is 11, third term is 29, fourth term is 83, and the fifth term is 245. All right, so we'll add 6, finding the first differences. Then we're going to add 18. And then 83 minus 30 would be 53. That's going to be 52. Oh, there might be a mistake in this one. Yeah, there might be a mistake in this one. 18 times 3, 54. It's supposed to be 54 there, so I'm going to change this number here. I know that's supposed to be 54, and if I add 54, I'm going to get 83, which is what I was supposed to get. I guess I just don't know how to subtract. Yeah, I went the wrong way. Sorry, going a little too fast for myself. All right, that's okay. That's a good thing that wasn't a mistake there. I just subtracted wrong. So it's the first difference are plus 6, plus 18, plus 54. And then 245 minus 83 is going to end in 162. Now, I don't know if you realize this, but if I multiply by 3, 6 times 3 is 18. Multiply 18 by 3, I get 54. Multiply 54 by 3, I get 162. This is an exponential function. This is exponential. Exponential. All right, so I'm going to take that times 3. and I'm going to raise it to the power of n. That's what I do in the exponential situation. All right, so we're going to go 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, and 3 to the fifth. 3 to the first is 3, 9, 27, 81, 243. And look at that, they're all too short of where they're supposed to be. I need to add 2 to all the black numbers to turn them into the blue line of numbers, right? So the nth term is going to be 3 to the power n plus 2, like that. My function will be f of x equals 3 to the power of x plus 2. And then I have to do f of 7, which is going to be 3 to the 7th power plus 2. I know 3 to the 5th is 243. 243 times 3 should be 729. If I multiply that by 3, I'm going to get 7 carry the 2. It's going to be an 8. 2187. Then I got to add 2 to it. So f of 7 will end up equaling 2,189. And there you go. All right. Changing directions a little bit, arithmetic and geometric sequences. And you guys are getting really good at these. So I've got problems 5 and 6. If you'd like to pause the video and solve them both, that would be awesome. On problem 5, you're finding a of 26, and on problem 6, you're finding a of 8. So there's your equations, your formulas. All right, here comes my solution. I'm going to do a of 26. This is arithmetic because it's what? Plus 3. Oh, no, it's minus 3. Minus 3, big deal. Minus 3, minus 3, minus 3 every time. So it's arithmetic. So I'm going to do a sub 1. Well, I know a sub 1 minus 3 times n minus 1. So a sub 26 equals 8 minus 3, and n is 26 because it's sitting right there. So this would be 26 minus 1, which is 25. So a sub 26 is going to equal 8 minus 75, because I did my multiplication first. 8 minus 75 is going to be 67, negative 67, right? There you go. Okay, this one here I think is geometric because I'm dividing by 3 and dividing by 3 and dividing by 3 every time. And dividing by 3 is the same as multiplying by the reciprocal, 1/3. So r is going to equal 1/3. So I need a sub 8. That's going to equal a sub 1, which is going to be 81, times 1/3 raised to the n minus 1 power. Well, n is 8, so that'll be the 7th power. So I'm going to get a sub 8, and that's going to equal 81 over 1 times 1 over, what was that, 2,000, oh, I can't remember. I just figured it out. Remember 3 to the 7th? 2,187. So 2,187. Now that's going to divide nicely. That's going to come out to be a nice fraction because I think 81 is going into both of them. So watch. Let me divide 2187 by 81. As soon as my calculator opens up. Okay, so 2,187 divided by 3, no, divided by 81, excuse me. 81, not 91. And it came out to 27 on the nose. So, be careful when you divide this. 81 goes into 81 one time. 81 goes into that 27 times. And so my answer is 1 in my numerator and a 27 in my denominator. All right, 2 more problems and then the video is done. Number 7, I have to find a sub 1. If a sub 10, I'm in the middle of recording. A sub 10 equals 40, r equals 2, and it's a geometric sequence. So first thing I'm going to do is write down my geometric formula. And that'll be what, to the n minus 1. And I'm going to fill in everything I know. A sub 10, and then a sub 1. I don't know. That's what I'm trying to find. R is 2. N is 10. So this will be 10 minus 1. So I really have a sub 10, which is 40, so I'll put a 40 in a sub 10's place. A sub 1 I'm trying to find. 2 will be raised to the 9th power. So I have, I'll just go down here, 40 equals a sub 1 times 2 to the 9th. Well, I think that's 512. Let me double check. 64 is 2 to the 6th, 2 to the 7th, 128, 2 to the 8th, be 256, yeah, 2 to the 9th, 512. All right, so now I'm going to divide by 512 on both sides. So then a sub 1 is going to equal 40 over 512. I know that 4 goes into both of those, so I'm going to divide by 4 and get 10. Divide by 4 there. Let's see, 512 divided by 4 is going to go 100. 11 is going to go twice. 8, be 32. So that would be 128. Now this can simplify further, so I'll divide them both by 2. I'm going to divide by 2, I'm going to get 5. And then I'm going to get 64. So the answer for a sub 1 is 5/64. Okay? All right, last problem, and then we'll call it quits for the day. Here we go. A sub 1, got to find a sub 1 if a sub 80 equals 300 and d equals 12 for an arithmetic sequence. So need the arithmetic formula. A sub 1 plus d times quantity of n minus 1. So that's a sub 80. I don't know a sub 1. I'm trying to find it. D is 12, and that'll be 80 minus 1. Okay, a sub 80 is 300. Equal a sub 1 plus 12 times 79. All right, well, let me see here. 12 times 8 is 96, isn't it? 960. Take away 12 is going to be 948. I believe that 12 times 79 is 948. Let's try it. 12. Oh, I'm in draw mode. Sorry about that. Oh, I'm doing it again. Let's get into... All right, we're going to do 12 times 79 and 948, and I believe that is what I said. So, yep, 948. Good. So, now I have 300 equals a sub 1 plus 948. And now I'll subtract 948 from both sides. And I know that 948 minus 300 is 648. So, negative 300, positive 300, and a negative 948 must be a negative 648, negative 648. So a sub 1 is going to equal negative 648. And there you go. All right, that's your video for the weekend. Mr. Laurence signing off. Have a good night, everybody.